Hello students, now we will move further with some more properties of inverse trigonometric function. Here some properties are already written. We are going to verify all these properties one by one. After that we are going to solve some more questions on the basis of these properties. First we have to start verifying these properties from property number 1, that is sin inverse x plus cos inverse x equals to pi by 2. So we can take, let sin inverse x equals to theta, then we can get the value of x, that is sin theta. If we have to convert this sine function in terms of cos, then we can write it as a sin cos 90 minus theta, and now we can transpose the cos. It becomes cos inverse x, that is pi by 2 minus theta, and the value of theta is sin inverse x. So cos inverse x equals to pi by 2 minus sin inverse x. If we have to transpose this sin inverse x, we get sin inverse x plus cos inverse x equals to pi by 2. This is the basic verification of property number 1. Please note it down. Then we can move further for the second property. Now, our second property is tan inverse x plus cot inverse x equals to pi by 2. Now, let tan inverse x equals to theta. From this we can find the value of x, that is tan theta, and if we have to convert this tan function in terms of cot, then we can write cot pi by 2 minus theta. Now transpose this cot, we get cot inverse x equals to pi by 2 minus theta, and the value of theta is tan inverse x. Just substitute it here. It becomes tan inverse x, and when we transpose, we get tan inverse x plus cot inverse x equals to pi by 2. These properties are very important because these all properties are going to use in calculus part. So please try to learn it as soon as possible. Okay. Then now we are moving further with the third property. The third property is sec inverse x plus cosec inverse x equals to pi by 2. Now we need to verify this function. Then first of all we can let sec inverse x equals to theta. From this we can get the value of x, that is sec theta, and if we have to convert this sec function in terms of cosec, we get cosec pi by 2 minus theta, and we can transpose this cosec term and we get cosec inverse x equals to pi by 2 minus theta. Now we can substitute the value of theta equals to pi by 2 minus sec inverse x, and if we transpose the value of sec inverse x, we get sec inverse x plus cosec inverse x equals to pi by 2. I hope this is clear to all of you. So now pause the video to note it down. We can move further for the fourth property. Our fourth property is, these are basically two properties, with one with plus sign. When we take plus here, either here plus and here minus, and when we take negative here, then it will become here negative and here positive. Means I will show you tan inverse x plus tan inverse y equals to tan inverse x plus y upon 1 minus xy. Okay. Now moving with this property, let tan inverse x equals to A and tan inverse y equals to B. From here we get the value of x, that is tan A, and value of y, that is tan B. Now we know that tan A plus B equals to tan A plus tan B upon 1 minus tan A tan B. If we have to find the value of A plus B, then we get tan inverse tan A plus tan B upon 1 minus tan A into tan B. Now substitute the value. Value of A is tan inverse x plus value of B is tan inverse y equals to tan inverse tan A is equals to x, tan B is y, so upon 1 minus x. Here we can get the other property. If we can put these values in tan A minus B, that is tan A minus tan B upon 1 minus tan A into tan B. A minus B equals to tan inverse tan A minus tan B upon 1 plus tan A into tan B. If we can substitute the value of A and B, that is tan inverse x tan inverse x minus tan inverse y equals to tan inverse x minus y upon 1 plus xy. So this is the another property. So please note it down first, then we can move further. Now our next property is sin inverse x plus sin inverse y equals to sin inverse x root 1 minus y square plus y root 1 minus x square. This also is done in same manner. Let sin inverse x equals to A and sin inverse y equals to V. From this, in the value of A is, so the value of x is sin A and the value of y is sin B. Now we know that sin A plus B equals to sin A cos B plus cos A sin B. Here we have all the values in terms of sine. So we have to convert these two cos term as well in sine. So we can write sin A into, this one is 1 minus sin square B plus, it could be written as 1 minus sin square A, it is sin B. Now you can substitute the value. Before substituting, transpose this sine function. So we get A plus B equals to sin inverse sin A root 1 minus sin square B plus sin B 1 minus sin square A. Now you can substitute the value. Here A is equals to sin inverse x plus sin inverse y equals to sin inverse, sin A is x root 1 minus y square plus y root 1 minus x square. So this is the required equation of sin inverse x plus sin inverse y. In the same manner, you can solve sin a minus b equals to sin a root 1 minus sin square b minus sin b into root 1 minus sin square a. Now just transpose this sine function, you get sin inverse sin a square root of 1 minus sin square b minus sin b square root of 1 minus sin square a. Now if we substitute the value, we get sin inverse x minus sin inverse y equals to sin inverse x root 1 minus y square minus y root 1 minus x square. So this is the required equation for sin inverse x minus sin inverse y. Now please pause the video to note it down. Okay, now moving further with our next equation, that is cos inverse x plus cos inverse y, that is cos inverse xy minus square root of 1 minus x square 1 minus y square. We can solve this as the same. First, let cos inverse x equals to a and cos inverse y equals to b. From this we can get the value of x, that is cos a, and the value of y, that is cos b. We know that cos a plus b equals to cos a cos b minus sin a sin b. If we have to write the whole equation in terms of cos, then we have to convert these two terms. Then what can we write? We can write cos inverse cos a into cos b minus, it could be written as 1 minus cos square a into 1 minus cos square b. If we have to transpose this cos, we get a plus b equals to cos inverse cos a cos b minus 1 minus cos square a into 1 minus cos square b. If we have to substitute all the values from this given data or from this assumed data, we get cos inverse x plus cos inverse y equals to cos inverse x y minus 1 minus x square into 1 minus y square. This is our required equation of cos function. Similarly, if we will go with negative term, then cos a minus b is equals to cos a cos b plus sin a sin b. If we have to convert these sine terms again in terms of cos, then we get cos a cos b plus 1 minus cos square a into 1 minus cos square b, and substitute all the values. Before substituting, just transpose this cos term, cos a cos b plus cos square b. Now a is cos inverse x minus cos inverse y equals to cos inverse xy plus square root of 1 minus x square into square root of 1 minus y square. This is the required equation for cos function. Now before moving further, just pause the video to note it down. Now moving further, 2 tan inverse x equals to tan inverse 2x upon 1 minus x square. We have to convert this only in tan. After that, for in terms of sine, in terms of cos, we are using that conversion factor. Okay, so we will prove only for tan function. This identity, we have two methods. Either you can write this tan inverse x as a tan inverse x plus tan inverse x, then you can apply tan inverse x plus tan inverse y identity, that is tan inverse x plus y upon 1 minus xy. So it will become tan inverse x plus y upon 1 minus xy. If you can simplify, you will get 2x upon 1 minus x square. This is the first method, and the second method is you can took RHS part, that is tan inverse 2x upon 1 minus x square. Now you have to simplify this. For this we can assume the value of x equals to tan theta. Substitute this, so we get tan inverse 2 tan theta upon 1 minus tan square theta. 2 tan theta upon 1 minus tan square theta is the identity for tan to theta, so it will become tan to theta. So by self adjustment property, tan inverse से tan cancel, so we get 2 theta, and the value of theta is tan inverse x. So our answer is 2 tan inverse x, that is equals to LHS. Clear? Now if we have to convert this in term of sine, this is perpendicular, this is base, so we can find hypotenuse first, and we will get 1 plus x square. By Pythagoras theorem we get the hypotenuse this. Now you can write this in terms of sine, that is perpendicular 2x upon hypotenuse 1 plus x square. In terms of cos, base 1 minus x square, hypotenuse 1 plus x square, that is cos inverse. Clear? Now pause the video to note it down. Now moving towards the next question. 2 sin inverse x equals to sin inverse 2x square root of 1 minus x square. Let's take we also have two methods for this. Either we can consider this function as sin inverse x plus sin inverse x, or we can substitute the formula, that is sin inverse x plus sin inverse y, that is sin inverse x root 1 minus y square plus y root 1 minus x square. If we have to add these terms, we get 2x root 1 minus x square. Or we can substitute, we can take RHS, that is sin inverse 2x root 1 minus x square, then x equals to sin theta, and we get theta equals to sin inverse x. Substitute this, we get sin inverse 2 sin theta, then square root of 1 minus sin square theta. We know very well square root of 1 minus sin square theta is cos theta, so we can write this 2 sin theta into cos theta is sin 2 theta. Sin 2 theta. This will be simplified by self-adjusting property, so we get 2 theta, and the value of theta is sin inverse x, so we get 2 sin inverse x, that is equals to RHS. I hope this is clear. Please pause the video to note it down. Now moving towards next. Our next is 2 cos inverse x equals to cos inverse 2x square minus 1. We can solve this again with two methods. One is cos inverse x plus cos inverse x. So we can use the identity cos inverse x plus cos inverse y, and we get cos inverse x y minus 1 minus x square into 1 minus y square. Here x and y both are x. So we can simplify and get x square minus 1 minus x square. If we simplify this, so we get 2x square minus 1. That is what we want. Clear? And another part is, second alter method is, take RHS cos inverse 2x square minus 1. Let x equals to cos theta and theta equals to cos inverse x and substitute. We get cos inverse 2 cos square theta minus 1. That is 2 cos inverse theta means cos to theta, it will self-adjusting, then it becomes 2 theta and the value of theta is cos inverse x, so it becomes 2 cos inverse x. That is equals to LHS of the question. So note it down. Now moving towards next is 3 sin inverse x equals to sin inverse 3x minus 4x cube. Simply just take the RHS part, that is sin inverse 3x minus 4x cube. Let the value of x equals to sin theta and we get the value of theta equals to sin inverse x. Just substitute in this equation, we get 3 sin theta minus 4 sin cube theta. This is the identity for sin 3 theta. So now it will become self-adjusting. We get 3 theta and the value of theta is sin inverse x. That is equals to LHS. This is the final answer. Now moving towards the next identity, that is 3 cos inverse x. 3 cos inverse x equals to cos inverse 4x cube minus 3x. Just take RHS, that is cos inverse 4x cube minus 3x and let the value of x equals to cos theta. Because of this we get the value of theta equals to cos inverse x. Just substitute, it becomes 4 cos cube theta minus 3 cos theta. This is the identity for cos 3 theta. It will become self-adjusting 3 and the value of theta is 3 cos inverse x. That is equals to LHS part. Now moving towards the last identity, that is 3 tan inverse x equals to tan inverse 3x minus x cube upon 1 minus 3x square. Take RHS first, that is tan inverse 3x minus x cube upon 1 minus 3x square. Just substitute, let x equals to tan theta, so theta equals to tan inverse x. Substitute, so we get tan inverse 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. This is the identity for tan 3 theta, so it will become tan inverse tan 3 theta, so it becomes 3 tan inverse x. That is equals to LHS. That's all. So here we are completed with the verification of all the properties. Now in next video we are going to solve some questions on the basis of these properties, and that was the completion of this chapter. So that's all from my side. Thank you.